3.1a wants us to check if an ordered pair is a solution to a system. So here they're saying is the 3, -4 a solution to this following system here. What you need to do is put the ordered pair of x and y, is what the 3 and the -4 stand for, into each equation. And it has to work for each of them. If it fails for one, it fails for the system. So let's just start it off by doing, put the 3 in for x, the -4 in for y. So here we have -5 times 3 minus 6 times a -4. And we're going to see if it equals 9. So this is -15. This is going to be plus 24. -15 plus 24 is 9. So 9 equals 9 works. So we know it does work for the first one. So now we have to try the second one. So let's go ahead and put in 2 times 3 plus 3 times -4. And I'm just going to see what this one equals. So that's going to be 6 plus a -12. 6 plus -12 is -6. And it says here that it should equal -6, so it does work. So the math supports it. Don't forget to answer the question. Yes, this is a solution. 3.1b and c, we're going to solve a system by graphing, and then just say how many solutions are in the system based on the picture. So remember to graph, we like to have them in y equals mx plus b format, which these two are already in. So what I'm going to do for the first one is identify the m and the b. The m is in front of the x, or the slope, so it's 5/3. The b is 4. I'm going to graph that line. Remember, first plot the y-intercept at 4. From that point, move the slope. Slope is rise over run. So I rise 5, and I go to the right 3. So I have to extend my graph paper up a little bit here. Let's go ahead from this point. Rise 5, 1, 2, 3, 4, 5, over 3. That's going to be my point right there. And then I can come on in and draw that line. Now the next one, let's go ahead and identify for the second line. The slope here is -2/3. The y-intercept is -3. So I'm going to plot the y-intercept of -3 first, which is right here. From there, move the slope. This is rise, so it's -2, so down 2 to the right 3. So down 2 to the right 3 lands me here. If you connect the dots, we're going to get right about there. Now it looks like, for my graph isn't the best, but it looks like this may cross at about right here at this ordered pair. It looks as though it's at 1, 2, 3, 4, -4, -1 per my picture. Now if I put -4, -1 back into the system, it's not going to equal exactly, so I know my graph isn't exact. But graphing does have some limitations, and this is one of them, is trying to be very precise in your drawing. If your drawing here is reasonable and fairly accurate, I would give you credit. Now let's answer the second part though. How many solutions are there? Well, what you need to remember is a solution means how many times it crosses. It crosses once, so there's one solution to this problem. Let's try number 2. They want us to graph it. So if we first graph these two, we're going to notice it doesn't look like it's in y equals mx plus b format. So your best bet will probably be to get them to look like this. So we're going to have to do some algebra. So let's go to that first equation and rewrite it. So we have 12x minus 5y equals 30. I want to get y by itself, so subtract 12x from both sides. That leaves us with -5. I'm going to do -12x plus 30. And then I'm going to divide by -5 on both. That's going to give us y equals 12x over 5 minus 6. That's this first equation. What I want to do is identify the m and the b. The b is the -6. The slope is 12 over 5. So I'm going to go down to -6 on the y-intercept and plot a point. From there, I'm going to move the slope of up 12 to the right 5. So if you go up 12, this is going to be 6, that's going to be 12. To the right 5 is going to land me right here. If you connect these 2 points, you'll get this line right there. Now let's do the second one. We need to solve this for y. Let's subtract x from both sides first. That'll leave us with 5y equals negative x plus 35. Let's divide everything by 5. When you do that, I'm going to write it down here. Y equals negative 1x over 5 plus 7. So from that, the m and the b is 7, the m is negative 1 over 5. So I'm going to plot the y-intercept of 7, which is right here. From there, I'm going to go down 1 and to the right 5. When you do that and you connect it, we actually get that. We can clearly tell on here that there is one solution, and this one works out perfectly in terms of seeing it on the grid mark. So this ordered pair here is at the ordered pair 5, 5. So the answer is the ordered pair is 5, 5, and that is just one solution. So in this case, we got a graph that was very clean and graphed very precisely. If we were to put 5, 5 in here, it would actually work exactly for the system. Now, the one thing to remember, how do you know if there's no solution or many solutions? Let's say we graphed a system and it looked like these two lines right here. These two lines are parallel. They never intersect anywhere. In this case, if that happens, there is no solution. Versus if you had a system where you have one line is drawn and then a second line is drawn and it happens to land right on top of it, in that case they intersect in many places. Therefore here we would say there are many solutions. 3.2a and 3.3b, we're going to solve systems by substitution. Then we'll tell how many solutions there are algebraically. Now substitution says take one equation and solve it for a variable. This first equation is already solved for the variable y. So I know that y equals 4x plus 3. You then take that value and you find the y variable in the second equation, which is right here. And you take this value and you substitute it in there. So we're going to take the first equation, solve for y, substitute into the second one right here. When you do that, it's going to say 4x plus 3 equals 2x plus 1. If we solve this, I'm going to start by bringing the 2x over. So that's going to be 2x plus 3 equals 1. Subtract 3. 2x equals negative 2. Divide by 2. We get x is equal to negative 1. So if x is equal to negative 1, now we finish it off by taking that value and we plug it back into either one of these two. I'll just put it back into this first one. So I'm going to say y equals 4 times the negative 1 plus 3. If you simplify this, it's negative 4 plus 3, or negative 1. So the answer here is where do they intersect? They're going to intersect at the ordered pair negative 1, 1. And then the question is, how many solutions is there? That's only one solution. It's where they cross. Now if we do the next one here, it's not set up as this is already solved for one variable. So you're going to look at your system and for substitution, figure out of this, 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 or this term, which one is easier to get by itself. This y right here is very clean, so it might be very easy to get the y by itself. To get this y by itself, we have to move the minus 5x. To move negative 5x, we would just add 5x to both sides. So I'm going to show that right here. So therefore we would get y equals 22 plus 5x. So what we just did, we solved one variable for a value. So I know y equals 22 plus 5x, and I got that from this first equation. Because I used the first equation, this value has to be substituted into the second equation. So all you do is find the y value, which is right here. You put this whole piece in for y. So I'm going to take that and put it right there. So when we solve, it's to be negative 5x minus 3 times 22 plus 5x equals 14. Now to solve this, be careful, we do have to distribute. So negative 5x minus 66 minus 15x equals 14. I'm going to add these two like terms together and get negative 20x minus 66 equals 14. Then I'm going to finish this by adding 66 to both sides. It's going to give me negative 20x equals 80. Divide by negative 20 on both sides. We get x is negative 4. X is negative 4. I can put this x value back into either here and solve. I could put it here. I could put it here. I could have either one of these three equations. This one's going to be the least amount of work. So if I put this right into here and I solve, I'll get y equals 22 plus 5 times negative 4. That's 22 minus 20, or it's 2. So what I just discovered here is the answer is the ordered pair, negative 4 because that's x, and then 2 is the y. So negative 4, 2. There's only one answer here, so there's one solution. Now the one thing you want to remember is, how do you know when there are many solutions or no solutions? When you do the algebra and you actually don't get an ordered pair answer, then that's either many or none, and we'll touch on that when we come across it. 3.3a and 3.3b, now we're going to solve by linear combination. And again, tell how many solutions algebraically. Linear combination, remember, means you're going to add the two equations together. When you add down, what you're going to want to have happen, either the x's fall out or the y's are going to fall out. So you want them to be the same numbers but opposite signs. So here we have an x of negative 20 and we have an x of 4. We can make them the same numbers but opposite signs. Why don't we make them both 12 and negative 12? That's already negative 12. This one needs to become a positive 12, so we times it by 3. Remember, everything in that last second equation must be multiplied by 3, so don't forget to do that. When you rewrite this system, what it's now going to look like is negative 12x plus 5y equals 23. The second one is 12x. Now it's minus 6y equals negative 30. Now when you add down, the x's fall out. 5y minus 6y is negative 1y. 23 minus 30 is negative 7. To solve for this, just divide by negative 1 on both sides. When you do that, y is equal to 7. Now you want to find its corresponding x. So take the y value of 7 and either put it here or here. I'm going to use the second equation because they're smaller numbers. So that would give me 4x minus 2 times the 7 equals negative 10. It's 4x minus 14 equals negative 10. I need to move the 14, so I add 14 to both sides. That's going to give me 4x equals 4. Wrap it up by dividing by 4. X is 1. So where do these two lines intersect? They intersect at the ordered pair 1, 7. And that's our answer. How many solutions are there? Well, you got a solution, which means there is one solution. If you get an ordered pair, that's how many solutions it means there is. Now if we look at the second one here, we want to figure out how to get the x's and y's either canceled out. First, make sure they're lined up appropriately, and they are. So is there a way that we can make either the x's or the y's the same numbers but opposite signs? Now this one's a little tricky in that to make them the same numbers, what we can do is we can divide out something. I can do is make 24 and an 18. I could make them both become the number 6. To make 24 a 6, I would divide out a 4. So let me show you this. I'm going to take this and divide out a 4. So if I do that to all of these, what I'm going to get is 24 divided by 4 is 6x. Negative 28y divided by 4 is negative 7y. And negative 28 divided by 4 is negative 7. Now on this one, I want to make this not just a positive 6, but a negative 6. So what can you take 18 and divide it by to get 6? Well, you can divide it by a 3. So do 1/3. But be careful, this is a positive 6. I want to make this negative, so do a negative 1/3. So if I do 18 divided by negative 3, I'm going to get a negative 6. If I do negative 1/3 here, this will become positive. 21 divided by 3 is 7, so this actually becomes plus 7y. This one here becomes a positive, negative 21 and negative 1/3, and it's going to be a plus of 7. Now if you look at it, if we add straight down, it's set to go. 6x minus 6x is 0. Negative 7y plus 7y is 0. So 0 plus 0, negative 7 plus 7 is 0. You're going to notice we have no ordered pairs as an answer, so this one doesn't have one solution. The variables fall out. When the variables fall out and x and y are both gone, it's a unique case. It's either many solutions or no solutions. So you need to say, is this true? Does 0 equal 0? Well, yes, it does, so that means this situation has many solutions. Keeping in mind, if you were to graph these two lines, many solutions visually looks like two lines right smack dab on top of each other. Now let's look at 3.0a, choosing any method to solve. That's algebraic. So let's either choose to use substitution or linear combo. I'm going to first look at number 7, and this would work nicely for substitution. If you did substitution, what I would do is solve for x and then substitute it into here. But I'm actually going to use linear combination. The x's and y's are lined up. I need to be the same number but opposite signs. That's negative 5. I'm going to make this one positive 5. So I'm going to multiply the bottom by 5 and make sure every term gets it. When you rewrite it, it looks like negative 5x minus 4y equals negative 3. Then be careful, 5x minus 35y. And then this one is going to be minus 75. When you do that, when you add down, this is 0. This one right here is going to become negative 39y, and then down here, negative 78. If you divide both sides by negative 39, this actually works quite nicely. Y is going to end up being 2. Now if y is 2, I'm going to take that value, and I'm just going to put it right in there to find its corresponding x. So I'm going to write x minus 7 times 2 equals negative 15. So that's x minus 14 equals negative 15. I'm going to add 14 to both sides, and based on this, x is going to be negative 1. So the answer to this is the xy ordered pair. It's negative 1. 2 is our solution. Let's look at this next one. Linear combination works quite well for this too, but you have to be careful. They're not lined up. So I would first rewrite this system so the x's and y's are lined up. So let's do 6x plus y equals 6. Then negative 6x plus 2y equals 12. Now on here we can either get rid of the x's or the y's. Let's say we want to get rid of, let's choose to get rid of the x's in this case. They're already opposite signs. I want that to be 6 and I want this to be negative 6. So I'm going to multiply this by a positive 2. And don't forget, everything gets impacted by that. So when you rewrite it, 6x plus y equals 6. This would be negative 6x plus 4y equals 24. When you add down, x's fall out, this becomes 5y equals 30. Divide by 5, so here y is 6. If y is 6, I'm just going to take that value, I'm going to put it right there. So then we get 6 plus 6x equals 6. I'm going to subtract 6 from both sides. That gives me 6x equals 0. If we divide by 6, 0 divided by 6 is 0. So the ordered pair answer here is the ordered pair 0. 6 is the solution. Point OB, we're going to solve word problems using a system. So for each word problem, write out 2 equations and 2 variables, then use any method to solve. So here we have 17 coins in your pocket made up of quarters and dimes. We have $3.50 in total. Determine how many of each coin you have in your pocket. So what they want us to do is to determine the coins. So let's define the variables first. Why don't we use Q for quarters, D for dimes. We'll just say it's number of quarters, and then D is the number of dimes. So if you look at it, the very first statement here talks about we have 17 coins in our pocket. So that's going to be one equation. The next equation talks about we have $3.50. So in terms of the dollars. So one is about the quantity of coins and one about the value. So the first equation for the quantity of coins, if we know we have 17 coins in total, what equation could we write for that? Well, if Q is the number of quarters and D is the number of dimes, why don't we just add up all the quarters and the dimes, and there should be 17. Now in total, they are $3.50. So if you think about it, what if you have 5 quarters in your pocket? How much money is that worth? What would you do? Well, you would take 5 quarters times its value of 25 cents. So here we're going to do 0.25 times the number of quarters. And then plus, if we had 10 dimes in our pocket, how much money is that? Well, 10 dimes times 10 cents each, you would just do 10 cents each times the dimes, and that'll give you the value. Now here's the system, and you can solve it one of 2 ways, substitution or linear combo. This one works pretty well for substitution. I would suggest using the first equation and either solving for Q or solving for D. Why don't we go ahead and solve for D, and then we'll substitute that in. So to get D by itself, I'm going to subtract Q from both sides. And that's going to leave us with D equals 17 minus Q. So if D from the first equation equals this value, we've used the first equation, so we have to use the second equation. We're going to go and find D in the second equation, which is right here. We're going to replace it with this value. So let's take this amount and put it right there and see what we get. So we'll get this equation right here. Now we're going to have to go ahead and do our distribution. So it'll be 0.25Q plus 1.7 minus 0.10Q equals 350. Well, we can add these 2 like terms together. 0.25 minus 0.10 is going to be 0.15Q plus 1.7 equals 3.5. Now the next step of algebra you're going to do on here is to subtract the 1.7 from both sides. When you do that, we're going to have the 0.15Q equals 1.80. To find the number of quarters, divide by 0.15. When you do that, you will get that there's 12 quarters. So now we have to find how many dimes there are. Well, if there's 12 quarters, that would go right here. So then we know it's 12 plus how many dimes equals 17. The algebra would just say subtract 12 from both sides. Therefore, there's 5 dimes. So let's put this in context. I would just put words to it. There's 12 quarters, and then there are 5 dimes. That would be your final answer. Just don't leave the variable answers because you can't assume people understand what Q means and what D means. This question here, your first semester test, is worth 150 points. There's a total of 42 questions. Of those, there's 5-point questions and 2-point questions. The question is, how many of the 2-point and 5-point questions are there? So let's define those variables first. It's right here. It's how many of 2-point and 5-point questions are there. So the variables would be something like this. I'm going to say x is equal to the number of 2-point questions and y is the number of 5-point questions. Again, the 2 things I know is I know the point values on the test and how many questions there are. Let's start with this one first. There's 42 questions in total. How are we going to get that using the variables x and y? Well, this is the number of questions. We're just going to add x and y together, so it's going to be x plus y. Now, we know that there are 5-point questions and there's 2-point questions, and they total 150 points. Well, where do the 150 points come from? Well, if X is how many 2-point questions there are, let's say there were 10 2-point questions, how would you get the value? You would do 2 times that. So it's going to be 2x. And then y is how many 5-point questions there are, but we need to know how many points in total. So take how many there are and times them by their points value, 5y. Now this one can be solved again with substitution or linear combo. Why don't we go ahead and do linear combination, and I'm going to eliminate the x's. That's a positive 2y. Let's make this one a negative 2y. So I'm going to multiply this entire equation by negative 2. Make sure it distributes through. When you rewrite that, it's going to be negative 2x minus 2y equals negative 84. And then we still have the second equation right here. When you add down on here, the x's fall out, the y's become 3y, and negative 84 plus 150 is going to be 66. Finish solving by dividing by 3. So y is, there's going to be 22. So there's 22 5-point questions. Therefore, how many 2-point questions are there? All we do is we're going to put the 22 in for y. So x plus 22 equals 42. Subtract the 22. We know that there has to be 20. So let's answer the question. There's 20 2-point questions, and there's 22 5-point questions. And we're done. The next one here, we have $243 to spend for door prizes at a school holiday party. And we have to spend the entire amount. We're going to buy 12 presents in total. And we're either going to purchase $15 for each CD or $22 for each DVD. Determine how many of each prize you should purchase. So we have 2 prizes. We have the CDs. I'll put number of CDs for C, and D is the number of DVDs. And the 2 things we were talking about is the price in total and how many. So if we add up the CDs and the DVDs, there's 12. So it's C plus D equals 12. The value of them are $243. Well, again, how many CDs am I going to purchase? And then each CD is $15. So if I purchase 2, I do 2 times 15. I don't know that, but I just do 15 times C. Each DVD is worth $22, so however many I purchase up here in the quantity, I would times it by 22. So 22D. Now we have our system, and we can solve by substitution or linear combination. Let's go ahead and actually do substitution for this one. Why don't we take this first equation and solve it for C? So if we do that, I'm going to subtract D from both sides. That would say C is equal to 12 minus D. C is that whole value, and I use the first equation. So this C has to go into the second equation. So let's replace that right there. When we do it, we're going to get 15 times 12 minus D plus the 22D equals 243. We're going to come in and distribute. That'll get us 180 minus 15D plus 22D equals 243. We can combine our like terms. So we have 180. This will be plus 7D equals 243. Now I'm going to subtract 180 from both sides. When you subtract 180 from both sides, you're going to get 7D equals 63. To get D by itself, divide by 7. D is going to be 9. So in this case, if there's 9 DVDs, we know that there would have to be 3 CDs. So I'm going to answer the question. There's 3 CDs and 9 DVDs, and that's our answer. Here the musical Grease was running at the Orpheum. One showing, there were 321 people in the attendance, and the play collected a total of $15,900. The price for adult tickets was $60, and the price of child tickets were $40. estimate how many adults and how many children were in attendance. So let's just go ahead and let's do X and Y. And 1 is going to be the number of adults, and let's have Y be the number of kids. And the two things we're dealing with here is we have how many people were in total and how much money they made. So if all the adults and kids combined together, there were 321. Now each adult ticket costs $60, so however many tickets were sold times 60 is going to help us get our total price of $15,900. So we're going to take an adult ticket times 60, so 60x. Y are the kid tickets. The kid tickets are $40 each, so however many tickets times the $40 would be plus 40y. Now again, we can do substitution or linear combination. Let's do linear combination this time, and why don't we eliminate the y? This is positive 40. Let's make this negative 40. So I'll multiply this whole thing by negative 40. We'll distribute that through, and we're going to get negative 40x minus 40y equals, this would be a negative 12,840. And then don't forget to rewrite the second equation. Now when we combine these two equations together and you add down, we're going to end up with 20 x's. The y's fall out. And then this side over here is going to equal 3,060. To get x by itself, divide by 20. When you do that, you're going to get that x is equal to 153. If x is 153, let's put that back in here and solve. So 153 plus some value is 321. Subtract 153 from both sides, and that's going to give you 168. Now do answer the question. Be careful what the variables stand for. So there's 153 adult tickets, and there were 168 children. And that's our final answer.